Okay, this is Project Test 6, Video 1, and will be problems 1 through 10. Researchers conducted a telephone survey of 427 adults living in a large city. The adults were asked whether they plan to purchase a smartwatch in the next year. The table shows the responses categorized by region. Which of the following graphical displays is most appropriate for comparing the proportions of those surveyed who plan to purchase a smartwatch within the 4 regions? Well, there's a key phrase here that says this data is categorical data. And the fact that we're working with proportions also indicates that as well. So because we're working with categorical data, we need to be considering a segmented bar chart. All right. The others are more quantitative, and this scatter plot is bivariate. So this scatter plot would be bivariate data where you have an X and Y. And the remaining are quantitative in nature, are better for quantitative. So the best choice would be the segmented bar chart. Okay, moving on to number 2. A scientist recorded the duration of the eruptions of Old Faithful, Geyser, and Yellowstone National Park that occurred during a 1-month period. The histogram below shows the distribution of the duration in seconds of the eruptions. And when I look at this, the very first thing I see is 2 peaks or 2 groups. So I'm right away going, you know what? It's bimodal. And whenever you have bimodal, you need to discuss the location of the clusters. And you should give center of each cluster. So based on the histogram, which of the following is the best description of the distribution? The distribution is uniform. Well, if it's uniform, that means it's going to be approximately flat. Now, we may have some up and down, but it's approximately flat. Obviously, this is not uniform. The distribution is skewed to the left. If it were to be skewed to the left, it would look something like this. So obviously not skewed to the left, skewed to the right, basically the same type of graph. So this is skewed left. Skewed right is going to look like it has a big tail on the right-hand side. So this would be skewed right. I should probably put a T on there for right. The distribution displays 2 clusters. This is D, and I like that right away because yes, it does. And it has a range of at most 200. Well, my range could be anywhere from 325 to 75. So 325 minus 75 is about 250. So I'm not too fond of this 200. So D is probably not my answer unless I've misread something. The distribution displays 2 clusters with one cluster centered at about 125. That looks pretty good. I like the fact that they gave the center. And the other is centered at about 260. And I'm not sure exactly, but somewhere between 250 and 275. So 260 sounds pretty good. And the range of at most 250, which is what we previously calculated. So E is my best choice. All right. Number 3, events D and E are independent with the probability of D equaling 0.6 and the probability of D and E equaling 0.18. Which of the following is true? Now, they gave us a big piece of information here. They said that they're independent. So if they're independent, the probability of D times the probability of E equals the probability of D and E. So I can go ahead and plug in and I go, well, 0.6 times E equals 0.18. And I divide both sides by 0.6. And I find out that E equals 0.30. And I immediately go, okay, do they have that answer choice? And they don't. Of course they don't. But we know E is not equal to 0.12 and E is not equal to 0.14. So we're now looking at a D or E. Well, the or is a sign for, or the word for union. So we need to look at what that formula looks like. So the probability of D union E equals the probability of D plus the probability of E minus the probability of D and E, or D intersect E. Well, we know D is 0.6. They gave us that. We calculated E as being 0.3. And they told us the intersection was 0.18. Because when they give us the word and, that means intersection. So when I add these up, I end up with 0.9 minus 0.18 equals 0.72. My best answer is D for number 3. So, all right, going on to number 4. Researchers used 2 footballs of the same size to examine the effect of helium on kicking distance. One football was filled with air and the other was filled with helium. So we have 2 footballs, all right, very important. 11 people participated in the study. Each person kicked the football filled with air and the football filled with helium. Oh, that's important. Each person did both. If they're doing both, this is probably some sort of a paired t-test. All right. So the kicking distance in yards were recorded. The football that was kicked first was determined by a flip of a coin, and the people did not know which football was filled with air and which was filled with helium. What type of study was conducted by the researchers? And of the following, which is the appropriate t-interval for inference? So we just basically said that they were tested twice, so this is going to be a paired. So it gets us down to B and C. And we have to be very, very careful here. A match pair design and a t-interval, I like that, for a difference mean between means for independent samples. Well, that would mean that I'd have to have 2 separate samples. And that's not what happened. All right. So let's look at C, or look at D. A match pair design and a t-interval for a mean difference. So basically they're saying mean difference or mu D. This is the case. Now let's go back and clarify a little bit. For C, it'd have to be 2 separate independent samples. And so basically we'd have a group of people who only kicked the helium football, and we took the average of their kicks, and we had a group of people who were randomly assigned to only kick the ones with the air, and we take the average of the air and the average of the helium and subtract them. But that's not what happened. We had one person kicking both, or actually we had 11 people, but they were kicking both. We didn't have 2 separate groups. Once again, to be a difference of means, we'd have to have 2 independent samples, and we didn't have that. So we had a mean difference, or a mu D, okay? All right, number 5. A survey of a random sample of 1,045 young adults. So we have N equals 1,045. Found that 60% do not have a landline telephone. A hypothesis test will be used to determine whether the data provide convincing statistical evidence that more than 50% of all young adults do not have a landline telephone. So I'm going to go ahead and do my null and alternative. I find that these help out a whole lot when we're doing type problems like this. So once again, this is a proportion, and they want to know the probability that is greater than more than 50%, so greater than 0.50. That means my null would be equal to 0.50, which then helps me out, and I know that the 60%, which came from the sample, and it should make sense, is 0.60 is my p hat. Which of the following is a test statistic for the appropriate test? Well, first off, every time we're working with proportions, which we obviously are here, we're working with a z-test, and our formula is z equals p hat minus p naught, where this goes for the null hypothesis, square root of p naught, q naught, and n. Okay? So this would be for a hypothesis test, which is what we're running. So when I plug in, I'm going to have 0.60 minus 0.50 over 0.50 times 0.50 over 1,045. Okay? So number 5, the best answer is C, 60% minus the 50%, and then we have it here. Now, please note, this is the standard error for a hypothesis test. So that's the standard error for a hypothesis test. Had they asked for a confidence interval, it would have been different. We would have gone p hat plus or minus z star p hat q hat n. So this one is based on the claim. So hypothesis tests are based on the claim, whereas a confidence interval, the standard error is based on the sample proportion. Population proportion, sample proportion. Hypothesis test, confidence interval. Please do not get those confused. Number 6. An airline recorded the number of on-time arrivals for a sample of 100 flights each day. The box plot below summarizes the data recorded for 1 year. Based on the box plot, which of the following statements must be true? And remember, 25% of my data is right here. Another 0.25 is right here. Another 0.25 is there, and another 0.25 is there. So the range of the number of on times is greater than 90, and no, because this is 92, about 94, and this is about 72. So 94 minus 72 equals 22. So the range is about 22. So that's obviously false. The interquartile range of on-time arrivals is 22. No, the range is 22. The IQR would be 72, 74, 76. So the IQR would be 80 minus 76. So our IQR is about 4. So that's false. The number of days that at least 80 on-time arrivals is greater. So at least 80, that means from here up, well, that's 25%. So 25% of my scores are greater than the number of days at most 76. And 2, 4, 6, that's also 25%. So now we have 0.25, 25% equals 25%. We have the same amount. That's not greater. The number of days that had from 76 to 80, from 76 to 80, well, that's 2. That from 76 to 80 is 50%, because here's 76, so to 80, so that's 50%, is equal to the number of days that I had most 76. Well, 76 is right here, and 50 does not equal 0.25, so D is also false. The difference between the mean and the lower quartile for the number of arrivals is less than 2. The median and the lower quartile. Well, the median happens to be at right here, and the lower quartile is at 76. I don't know exactly where this is at, but it's probably about 77. So the median of a 77 minus 76 equals 1, and that is less than 2. So the best answer for number 6 is, in fact, E. All right, number 7. A tropical storm is classified as major if it sustained winds greater than 110 miles per hour. Based on the data from the past 2 decades, a meteorologist estimated the following percentages about future storms. 20% of all storms will originate in the Atlantic, of which 20% will be classified as major. 30% of all tropical storms originate in the Eastern Pacific, which 15% will be classified as major. 50% of all tropical storms will in the Western Pacific, of which 25% will be classified as major. Based on the meteorologist's estimates, approximately what is the probability that a future storm will originate in the Pacific Ocean? Well, these are the ones that originate in the Pacific Ocean and be classified as major. So 0.30, 30% are in the Eastern Pacific. Of that group, 15% will be major. In the Western Pacific, we have 50%, of which 25% will be considered major. So we have Eastern Pacific plus Western Pacific storms, and that makes up the Pacific. So here we go with the calculator. 0.3 times 0.15 plus 0.5 times 0.25, and I equal about 17%. So the best answer for 7 is C. All right. Researchers indicated that the standard deviation of human body temperature is 0.4 degrees Celsius. Which of the following represents the standard deviation of the human body temperature in degrees Fahrenheit, where F equals 9/5 C plus 32? So all I need to do is plug in to that formula. Well, 9/5 times 4 plus 32. Please remember, we cannot add a constant to measures of spread. And standard deviation is a measure of spread. So 9/5 times 4, or 0.4, is my answer. Now, I'm going to take a moment and talk about variance. This is the standard deviation. Standard deviation equals 0.4. And so if I wanted to do the same thing with the variance, I would just go ahead and square this. And I plug into this equation, and variance is the one that's different. Again, we can't add a constant because it's a measure of spread, but we also have to square the constant that we're multiplying by. So this one, had they asked for it, would have been the variance. All right. We can use, the only time we have to square it is when we're working with variance. But when you're working with variance, you have to square it. Now, they didn't ask for that. So this is not the answer. The answer is B, because it's 9/5 times 0.4, and we don't add constants to measures of spread. The distribution of weights of female college cross-country runners is approximately normal with a mean of 122 and a standard deviation of 8. So if I'm drawing a picture of this, I have a mean of 122, and I have a standard deviation equal to 8. Which is the closest to the percent of the runners who weigh between 114 and 138? So 114 to 138, this is what I'm looking for. All right. Now the calculator is going to do this for us in all one step, but I'm going to show you how to do it if this had been an FRQ test. So we want the probability that 114 is less than X is less than 138. And of course, we're going to be using our Z formula, Z equals X minus mu over sigma. So we want the probability that Z is less than 138 minus our mean of 122 over the standard deviation of 8 minus the probability that Z is less than 114 minus 122 over 8. So that's what the work would be if we were doing it on an FRQ test. For our calculator, we're just going to do a normal CDF. And our lower bound is the 114. Our upper bound is the 138. Our mean happens to be 122. And our standard deviation is 8. Lower, upper, mean, standard deviation. So here we go. Second VARS, normal, CDF, lower bound, 114, upper bound, 138, mean, 122, standard deviation is 8, and we end up getting 0.818, or about 82%. So for number 9, our answer is D. Measurements of water quality were taken from a river downstream from an abandoned chemical dump site. Concentrations of a certain chemical were obtained from 9 measurements taken at the surface of the water, then 9 measurements taken at the mid depth of the water, and 9 measurements taken at the bottom of the water. What type of study was conducted, and what was the response variable? All right. So first off, what are we doing? Well, we're doing a survey. Basically, we didn't assign the chemicals, so this is not an experiment. This is an observational study. It's not a census because we didn't measure all the water. A census wouldn't even been possible. So this is an observational study, and it's actually a stratified sample because we're taking 9 at the surface, 9 in the middle, and 9 at the depth, at the deep points. And our response variable is the concentration of the chemical, because that's what we're measuring. We're measuring the concentration of the chemical. So our answer to number 10 is D. All right, thank you.